All right, everybody, we are going to try this and see how it goes. So if you have questions as I'm going, feel free to put them in the chat. I'll try to monitor that as best I can as we are doing this. So let's take a look at number 1. I'm going to go over the ones even that I know you got, just because if you wanted a little bit more help with them, you can get that here. So we have 4 minus 2/3 x is greater than 2 minus x. We can treat this inequality sign the same as we would an equal sign. The only difference is that if we need to divide or multiply by a negative number, we'll need to flip the sign. But otherwise, you treat it the same way that you would treat an equal sign, which means we want to get our variable on one side, and then we want to get our constant on the other side so that we can solve for x. So I'm going to do that first by adding x to both sides. And I'm going to do that because negative x and positive x will cancel out. And then what this will do is I'm adding 1x is the same as 3/3 x. And so that'll leave me with a nice positive number. So I'll have 4 plus 1/3 x is greater than 2. Now I need to get this 4 to the other side, so I'm going to subtract 4 from both sides, and I'll get 1/3 x is greater than negative 2. I'm then going to multiply times the reciprocal because I'm dividing. If you want to divide by 1/3, we would multiply by 3/1 because 3/1 times 1/3 is going to give us 1, or just x. And so that means x will be greater than negative 6. And so on my graph, I'm going to find negative 6. I'm going to draw an open circle because it is greater than, not greater than or equal to. That's confusing because I just underlined that, but that. And then greater than, it's going to be going in this direction. Now on the test, if you're not sure, you can always take a point, right, and plug it into the equation and see if it works. If it works, you know you went the right way. If it doesn't work, then you went the wrong way. Okay? All right, problem 2 has this equation here. It's a good idea to always start just by writing your equation down if you're stuck with what to do. Now, thinking about what we did up above, you're doing the same thing down here. We want to get our variable on one side and our constants on the other. So I'm going to subtract c from both sides, and we'll get ax equals bx plus d minus c. And then I'm going to subtract b times x on this side so that I'm getting all of my x's on one side. So now I have ax minus bx equals d minus c. So now I can factor out this x. And so we can rewrite this as x times a minus b equals d minus c. And then to get x by itself, I can divide both sides by a minus b. And so you should have here d minus c over a minus b. So it'd be this one over this one here. Okay? If you have a situation where you have something being multiplied by the same variable, you can factor that variable out as such here, because a times x would be a times x, and x times negative b would be our negative bx. So we factor that out there. All right, let's take a look at problem 3. So in problem 3, we're solving an inequality again. Again, we're going to treat that less than sign the same way that we would treat it an equal sign. So again, I want to get my variables on one side and my constant on the other. So I'm going to subtract 2x from both sides. We'll get 3x minus 3 is less than 0. Now I want to add 3 to both sides. So I will get 3x is less than 3, divide both sides by 3, and we get x is less than 1. Again, this is a less than, so we have an open circle, and it's less than, so we're going to be going down that direction. All right, let's take a look at problem 4. So for problem 4, we are looking at completing the square. So it says to solve this equation by completing the square, a student could use the equivalent equation. So we're filling in what goes here and what goes on the equal side. Well, I'm going to have x squared minus x minus 2 equals 0. The first thing that I want to do is create space. So I'm going to add 2 to both sides here. So we get x squared minus x equals 2. To complete the square, remember I take half of my middle term and square it. So half of 1 or half of negative 1 is negative 1/2. Negative 1/2 squared is 1/4. So I'm adding 1/4 to both sides. Now this, I've created a perfect square, so I can rewrite that as what I took from my middle, that half part. So 1 as x minus 1/2 squared equals 2 1/4 or 9/4. All right, and so now I know that in the parentheses here, it already has a minus there. So what I'm putting in there is 1/2 and equals 9/4. Problem 5, what are the solutions to the equation? All right, so to find the solutions of the equation, the first thing that I need to do is work this problem out on this side. So I'm going to rewrite this as by foiling it. So 2x plus 1 times 2x plus 1 minus x minus 13. I'm distributing this negative through there, equals 3x squared minus 2x plus 2. All right, so now I'm going to go ahead and FOIL this. I'll get 4x squared plus 2x plus 2x. So plus 4x plus 1 minus x minus 13 equals 3x squared minus 2x plus 2. And then I am going to combine like terms. So 4x squared plus 3x minus 12 equals 3x squared minus 2x plus 2. Now there's a couple things you can do. You can plug this into your calculator and graph them and look for where they intersect. We can also just go ahead and move all of these to one side to set it equal to 0 and then factor. So I'm going to subtract 3x squared from both sides and I'll get x squared on this side. This will cancel out. I'm going to add 2x to both sides, so I'll get plus 5x. And then I'm going to subtract 2 on both sides, so I'll get minus 14 equals 0. And now I can factor. So I'm looking for factors that multiply to give me negative 14 and add to give me 5. That would be positive 7 and negative 2. That means my answers are x plus 7 equals 0, x minus 2 equals 0. So we have x equals negative 7 and x equals 2. All right, here it says, what is the sum of the roots of the equation? So to find the sum of the roots, I have to find the roots, right? And so we're going to start by, because we have a coefficient, multiplying our a times c, which is going to be negative 6. So I need to find factors of negative 6 that add up to give me 5. So I'm going to use positive 6 and negative 1. So positive 6x and minus x. I'm going to rewrite my equation. 2x squared plus 6x minus x minus 3. And then we're going to inverse FOIL. So 2x squared, 6x, negative x minus 3. I'm going to factor out here an x. That leaves us with 2x over here. This would be plus 3, and this would be minus 1. So my answers will be 2x minus 1 times x plus 3, which means my zeros or my roots are x can equal negative 3 or x can equal 1/2. And so if I add, it says sum, if I add negative 3 and 1/2, I will get negative 2.5. All right. Number 7 says which equations have no real solutions. So if you look at these right here, these are all perfect squares, or all have perfect squares in the first 4. So what we're going to look is if we were to solve this by taking the square root, right? If I divide both sides by 2, I'll still get 0 on the side. If I take the square root, I'll get the square root of 0, which is 0. So this I can solve. That has a real solution. This one down here, if I subtract 4 from both sides, I will get negative 3. And then I'll get negative 3 divided by 2. I cannot take the square root of a negative number and get a real solution. I will get a non-real solution or imaginary number. So B is an equation with no real solution. C, if I subtract 4 on both sides, I'll get this x minus 1 squared equals 4. I can take the square root of 4 and get a real answer. So this one would give me a real answer. Here, if I subtract 4 on both sides, I'm going to get negative 2 on this side. I cannot take the square root of negative 2 and get a real number, so this will produce unreal numbers or imaginary numbers. This one here is not written as a perfect square, but I can rewrite it as a perfect square by adding x squared plus 8x plus Half of 8 is 4 plus 16 equals negative 15 plus 16 is going to be 1. This would then be x plus 4 squared equals 1. I can take the square root of 1, so this one does produce real numbers. All right. Let's look at problem 8. Problem 8 says, determine whether the equations have real solutions or no real solutions. So we're moving these equations into here. So same thing, you want to try to see if you can factor them appropriately. You can also use the discriminant, so b squared minus 4ac, to see if this works. So here, this is 4x squared minus 2x plus 1 equals 0. So we have a, b, and c. B squared would be 4 minus 4 times a, so times 4 times c times 1. So this will give me 4 minus 16. That's going to give me a negative number. And so this is going to have no real solutions. Okay? Here I would get 3x squared plus 6x plus 3. So again, we would take b squared is 36. That's 6 squared, 6 times 6. 36 minus 4 times 3 times 3, which is 36 minus 36, which is 0. That still gives me a real solution. So this would be that one. It would only give me one real solution, but would it give me a real solution? And then here, same thing, b squared. So that would be 25 minus 4 times 2 times 7. So this would be 25 minus 42. Oh, no, sorry. 4 times 2 is 56. And so this would give us a negative number. If we take the square root of a negative number, that will not give us a real solution. So this is also going to be no real solutions. All right, let's look at number 9. So a small company manufactures a certain item and sells it online. The company has a model where the cost, C in dollars, to mark items is this equation here, and the revenue in dollars is made by selling X items is given R equals 10X. The break-even point is the point where the cost and the revenue equations intersect. So we're going to graph these. Let's start with C. So we're going to start at 50. That's our y-axis, or y-intercept. And then it's 20 over 3. Well, notice we're going in increments of 5, right? And so if we were to think about when this would be 5s, if we were to put it into 5s, we would multiply by 5. We would get 100 over 15, right? So that's the way that we're moving. We're moving up by 100 and over 15. All right, so up by 100 and over 15. You can always rewrite your equation, or your slope rather, to be an equivalent fraction that will be more friendly towards your graph. In this case, everything's going by 5s, so we would want that to also be going by 5s. So that would be a point there, and then you can connect your line. Okay, then the other line is R equals 10x. So that means I'm going up 10 over 1. But again, we want to be going over by 5, so we would change this to 50 over 5. So, and because I have no y-intercept, that means it passes through 0. So I'm going up 50 over 5, up 50 over 5, up 50 over 5. And so this would be right there, my point of intersection right here. So it says, how many items must the company sell to break even? That would be this meeting point here. And the items I have to sell at that point are 15. All right. This is match a correct description to the equations here. So x equals 2 means that no matter where we go on the graph, x will equal 2. So no matter what y equals, x will equal 2. So this will create a vertical line. Similarly, y equals 2 would do the opposite, right? It's going to be no matter where x is, y is going to equal positive 2 there. So this will be horizontal. And then this is an equation. If I were to rewrite it, it would be y equals negative x, which means the y-intercept is 0 here. And so this is a line containing origin. This is a proportional relationship in which for every 1 I move over, I'm going down 1. All right, line K contains these points in the xy coordinate plane. What are 2 other points that lie on line K? So to do that, I need to find the equation that will match for these points. So I'm going to start by finding the slope. And remember, our slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I'm going to do negative 8 minus 4. Sorry, my dog is whining. All over 9 minus negative 9. Negative 12 equals negative 9 minus a negative 9 is 9 plus 9, 18. I'm going to reduce this to make this friendlier, divide both sides, or both the numerator and denominator by 3, and we get, nope, just kidding, by 6. So 12 divided by 6 gives us 2, and 18 divided by 6 gives us 3. That's our slope now. Now I need to write the equation or the formula, and so I'm going to use my y minus, and I'm going to use these points here. I'll just use that first point. So y minus 4 equals negative 2/3 times x minus a negative 9. Y minus 4 equals negative 2/3 times x plus 9. All right, and so this is my equation. So if the points work, then I should be able to plug them in and they will work out to be true, right? So I'm going to simplify this equation a little bit to make it y minus 4 equals negative 2/3 x, negative 2/3 times 9. So 2 times 9 is 18. 18 divided by 3 is 6. It's times a negative, so minus 6. I'm going to add 4 to both sides, and we get y equals to negative 2/3 x minus 2. That's my equation. So I'm looking to see which of these I can plug in and have it be true. That part I'm not going to tell you the answer to. There is only one solution, but you need to plug in the points, and both of them need to work in order for you to be able to select that answer. All right, number 12 says these graphs intersect on the xy coordinate plane. What are the points of intersection? So you can graph these for sure and look for where they intersect. We can also write this as a equality and solve. So I'm going to rewrite this as, I'm going to move this way. So x squared minus 2x, subtract 7 from both sides, minus 8 equals 0. This will give me my zeros. And so I'm going to do x minus 4 times x plus 2, which means we have 4 and negative 2 for our x values. Now, to find the y value, I need to plug in my x values. So I can plug them in either equation and I'll still get the answer. So 4 times 2 is 8. 8 plus 7 is 15. So this would be 4 comma 15. Notice I can do that here. 4 squared is 16 minus 1 is 15. Negative 2 times 2 is negative 4 plus 7 is 3. So my other point is negative 2 comma 3. All right, I am going to pause here and I will start a second video in a little while for the second half.